Hey there, sixth graders. The day has finally come for us to start shifting away from modeling subtracting integers and start working toward an algorithm or a shortcut so that we can start subtracting integers without having to draw any pictures. Now, if you need to draw a picture, is that okay? Absolutely. I'm always down for models. There's nothing wrong with having to draw a picture or creating a visual for yourself. But I think in life, well, definitely in life, as you continue to get older, it's going to be really important that you know how to be able to subtract integers quickly and efficiently, just like it was really important for you to master your math, skills of addition and subtraction and multiplication and division facts. So what we're going to do for one last time is we are going to model these problems, and we're going to see if there's something similar about them. So off the bat, if I'm looking at these two problems, 1 and 2, 5 minus -3, 5 plus +3. So my operation is different and my sign of my second number is different, but the 5 is the same in both. So let's see if maybe there's a relationship between those. So let's just go ahead and focus on this first. I'm going to model what it means to subtract 3 negatives from 5 positives. So step 1 is to lay out 5 positives. Okay, so 1, 2, 3, 4, 5. 5 positives. I need to take away 3 negatives. My question to you, do I have any negatives on the mat to take away? No, I don't. I only have positives. So if you remember back to our counter method, what we're allowed to do is we can add on 0 pairs, because by adding on 0, we're adding nothing to the mat, even though we are adding something to the mat, which gets a little confusing. So I'm going to go ahead and add a 0 pair. I'm just going to add 1 for right now. If I add 1 0 pair, the total value of this mat is still +5. I've added 0 in the form of a +1 and a -1. Now I have 1 negative to take away. I don't want just 1 negative. I want 3 of them. I'm going to add another 0 pair. And another 0 pair, because now I have 3 negatives that I can drag away. And what am I left with? I am left with 8 positives. Okay, I'm left with 8 positives. We did not have enough, so we added 3 0 pairs. Okay? Let's take a look at 5 plus +3. So what we're going to do is we're going to lay out 5 positive chips. And then we are going to add 3 more positives. So here's my 5 positive chips. And I'm going to add 3 more positives. And my answer is +8. Oh my goodness. We got the same answer as 5 minus -3. This is not a coincidence. There is a relationship between subtracting negatives and adding positives. They represent the same problems. They are equivalent. And as you can see, the reason is because you're adding on 3 positives here with your 0 pairs, and you're taking away those 3 negatives. So ultimately, what you ended up doing was you added 3 positives, just like you did over here. Let's look at number line method. And these are the two I'm really going to be most interested about, because I want to test out if this subtracting the negative is indeed equivalent to adding a positive. Let's look using our number line method. Now this one is just to help remind us how to model this. So if I have 6 minus 3, we're going back to elementary school style. I start at 6. I need to move back 3 units because this is 3 positives. So just like you learned in elementary school, we're going to move back 1, 2, 3 spaces. Okay, and we get 3. Easy peasy. We're going to use this to help us now do this, because when I ask you to subtract 3 negatives on a number line, that's not so easy. Well, I'm dealing with 3 negatives, not 3 positives anymore, so I'm going to go in the opposite direction. So I'm going to start at 6. When I subtracted 3 positives, I moved to the left. So when I subtract 3 negatives, I'm going to do the opposite, and I'm going to move to the right. 1, 2, 3, and I get +9. And let's see if that ends up being the same scenario as 6 plus +3. Well, 6, going back to, first, second grade math, adding on a number line. If you're adding a positive, you move to the right. 1, 2, 3. And as you can see, we get the same exact solution. We're doing the same exact thing as subtracting that negative. So what do we notice? We notice that subtracting a negative is equal to adding a positive. That's a really strong conclusion there. And this does not only apply when you're subtracting negatives. It turns out, and we're going to discover on the back as well, that subtracting a positive is equal to adding a negative. So in general, when you're subtracting any integer, whether it's a positive or a negative, it is equal to adding the opposite of what you started with. We're going to call that keep, change, change. That's going to be our shortcut to remember how we subtract integers. So this is our shortcut finally. It does turn out that subtracting any integer is indeed the same thing as adding its opposite. You could model any integer problem till you're blue in the face. And if you model adding its opposite instead of subtracting that integer, you will get the same answer every time. So our shortcut is going to be called KCC, or keep, change, change. Kind of like keep, change, flip. And keep, change, flip was when we were dividing fractions. Keep, change, flip meant that dividing by a fraction is the same thing as multiplying by the reciprocal. Flip is a reciprocal. So with KCC, we're going to keep the first integer the same. We leave it alone. We are then going to change our operation from subtraction to addition. And we're going to change the second integer into its opposite. Opposites are things like positive 5 and negative 5. Negative 99 and positive 99. Okay, whoops. So we keep the first number the same, change subtraction to addition, and change that second number to its opposite. So let's look at an example. If I have 4 minus 10, I'm going to go ahead and put my KCC above it, and I'm going to create columns for myself. I know I'm kind of cutting into my sentence here, but that's okay. So I'm going to keep that first number the same. I keep the 4. I change subtraction to addition, and I change my positive 10 to negative 10. And now my problem is 4 plus negative 10. I have an addition problem, so now I think about the song for my shortcut. Same signs, add and keep, different signs, subtract. Take the sign of the higher number, then you'll be exact. So here I have different signs, so I'm actually going to subtract. 10 minus 4 is 6, and I have more negatives. That is negative 6. Let's do a couple of examples together. And this is the format I would like to see your work in. I would like to see your KCC. It's a good habit to get into so that we don't make any mistakes. I'm going to keep the 5 the same. I change subtraction to addition. I change my negative 10 to a positive 10. That's 5 plus 10, which is 15, and I'm done. Let's take a look at the next example. Let's go ahead and set up our KCC and our columns. This is going to be the same thing as 10 plus negative 20. Same signs, add and keep. Different signs, subtract. 20 minus 10 is 10. Keep the sign of the quote-unquote higher number, which is the negative 20. Our answer is negative 10. And the last one, KCC, set up those columns. Negative 13 plus positive 5, same signs, add and keep, different signs, subtract. 13 minus 5 is 8. There's more negatives, negative 8. So this is now the shortcut that you are now allowed to use moving forward.